Greetings, wonderful physics students. Making this one to help you out with number 7 here in your Unit 4 homework. So, the problem here, is all about this beam, which is connected by a pin right there. That's an important thing to realize. There's a pin supporting that, and that beam is effectively free to rotate through that point. Whoops. What happened there? A moment to go back and find that problem. There we go. Sorry about that. All right. And now, the reason that this beam isn't rotating is it's connected by this rope or string. That's this right here. So what you want to do is start with a free body diagram of the beam. Now, I would, if it were me, this is how I would define the system. I would just include these masses, like so. Right, there's your system. Now, you've got a weight, this green weight here. You need a force vector for this. You need a force vector for this, the 500 newtons. You have a tension. It's going to look something like so. And again, no reason to draw that to there. Length of the rope has nothing to do with the magnitude of that vector. Okay. And what one of the forces that people tend to miss is this. See, without this pin, this beam would just kick out. Like this would start accelerating in this direction. The pin keeps that from happening. So the pin is applying a force, maybe something like this. I'll put P for pin force on that beam. It's holding it to the right effectively and supporting it vertically. Now, the force direction is kind of unknown here. So it's an unknown magnitude and an unknown direction. And normally what we do is we tend to, write those in component form. That's what we're going to be doing anyway later on down the road. You would typically take that force and break it into components. So I would just put those force components in there like so. And, if it were me, I would call them something like PX and PY or something like that. So your complete free body should have 1, 2, 3. What does it say about the beam here? Doesn't really say. Oh, there it is. Significant weight on the beam. So you should have 3 weight vectors in your free body, a tension, and these 2 forces right here. All right. Next step here is to write a torque equation. And the big deal is that if you sum torques about this point, the Px and Py will not show up. You'll have a weight vector here, the 200 newtons times this distance, the weight of the beam, I'll just put this force vector there, also times this distance, the 500 newtons times this distance, and then here's an angle theta. Oh, let's see, measure the angles you need. Okay, so take a protractor or something, measure that angle theta, and think about that tension, this tension vector, in terms of components. You'll have a T sine theta and a T cosine theta. One of them will be creating torque, the other one not. So that should get you through number 7. Once you write out a torque equation, you should be able to get the tension. And then for anything else you need to find here, write a force equation x direction to get the force that I called Px. It was in this direction. You can then write a force equation in the y direction to get the Py. You also, by the way, could write a torque equation about any other point, maybe this point to get the Py. Any of those should work. So hope that gets you through that homework problem. Have a great day.